So again, welcome the Programmable Cisco Data Center. I'm going to hand it over to John Klossner, who is the Director of Network and Data Center Solutions for SMP. And with that, John, it's all you.
Thank you, Jennifer. Good morning, everyone. Thanks for joining us. Hope you're looking forward to a session that's a little out of the norm for us, right? And maybe a topic that's new to many of you. So I want to start this off just agenda, just a quick level set. So first of all, as I said, welcome. I'm going to touch on why is automation and programmability a topic worth us spending 90 minutes on today, and probably why it's worth your time going forward to continue to invest and grow your personal capabilities in this space. From there, I'm going to hand it off to Igor, who will take us through a brief presentation and a demonstration of programming your data center network using Ansible, followed by John Moorhead taking us through ACI, which is Cisco's data center fabric, and the Multisite Orchestrator. And then I'll close out, depending on how much time we have left, Cisco Intersight, which is a SaaS offering to manage Cisco's compute platform, UCS. All right. So why automate? Why programmability? Why are these things important today and now more than ever? The biggest thing on this slide to me, there's two things. So number one, security is top of mind for everyone as we've moved into the COVID world and even before. Cyber attacks are through the roof, and a lot of those are allowed to happen based on human error, right? And that human error a lot of times is because of complexities in platforms such as the cloud. Maybe our engineers are not totally comfortable, familiar with necessarily what they're deploying. And with the COVID, the downturn in the economy, more than ever, the ability to reduce your spend, your OpEx, drive towards business outcomes, and actually accelerate an ROI on anything that your company invests in is critically important. So why automate? We talk about the low-hanging fruit, right? So 95% of changes in your IT environment, this says network, but think of it as IT, are performed manually. So that's somebody going in command line, whether they've got it copy and pasted from a notepad, but it's a human doing those changes, 95%. When you couple that with the human error factor and policy violations, another 70%, and then you look at 75% of the OpEx spent in network or IT is spent on changes and troubleshooting. So that means you're spending a lot of your money or your company's money to keep the lights on, care and feeding. And there's a better way to do this. We're talking big money. I think this figure was from 2016, $60 billion spent on these things that can easily be automated and allow you time to focus on transformational and true value-oriented projects. I apologize if this slide's a little tough to pick up. The blues kind of blended here together for me. But here's some more stats, and this all came from IDC. So from an efficiency perspective, you can reduce the costs associated with operations by 77%, increase your ability to meet SLAs, reduce your time to provision services, and reallocate your IT budget from keeping the lights on to actually being strategic, which at the end of the day, per IDC, could result in 11% revenue growth for your organization. And really, at the end of the day, why are we doing it? Why is it important? Because it drives business value. What this slide illustrates is if just the network team, so if just Igor, for example, in our presentation is automating, that's great value for the network team. If Intersight and the compute team are doing automation, that's great value for their team. But what you really need to do is piece it all together and actually drive the strategic value of automation to the business. Make your on-prem and your public cloud infrastructure as dynamic as the business needs it to be to support where they're going. That's it for the overview. With that, I'm going to turn this over to Igor to jump into some good hands-on real-world stuff for you guys.
Hey, good morning, everyone. Thanks, John. Let me share out my screen. And are you seeing the right side of the slides or the wrong side?
No, sir. Got to swap them.
Swap them, yeah. How's that?
Perfect. Thank you.
All right. Good morning, everyone. So today we're going to talk about data center automation using Nexus NX OS and ACI fabrics. And we're going to talk about using Ansible as our tool to do that automation and how it all plays together. A little bit about the agenda, and I'll cover a little bit more about why automation matters, add on to some of the things that John said and then overlap some of the things that he's already said. We'll take a brief introduction to Ansible, what it is, how it works, and then we will dive into the demos. We'll have a few demos using NXOS with the Nexus 9000 switches, using Ansible to automate that. And also we'll look at how to automate ACI deployments with Ansible. So according to Gartner, right, so 71% of our networks are still driven manually via CLI. And that has worked for a long time for us, and it makes sense because we're comfortable with it. We've been doing it forever. But as John said, this brings out problems in security and complexity and error proneness to doing this approach, especially when we take a look at doing this on a greater scale. Greater scale than just one or two switches at a time. When we start doing this on a larger scale, errors start to show up, and they're harder to work with in a larger environment. And that's why automation will start to make sense, right? So automation happens when one person in the environment finds a problem that they have to tackle that they never want to tackle again, right? Things like deploying hundreds of switches, right? And I've been through it, right? Been through deployments where we have to deploy hundreds of switches. We've done it the old way of having a template that we copy and paste onto a switch. And what happens, 85% through the job, we find out that there's an error in the template, and now we need to go back and make a change and start again. And the complexities that arise with that and the time inefficiencies that resolve out of that type of a process are really something that we can do better with. So with that, Nexus operating system has a feature set called NX API. That feature is enabled like any other feature using the feature command. In this case, there's a little snippet there, feature NX API. And what that does is it exposes the programmability APIs that are found in Nexus OS. You are able to now make structured REST API calls using HTTP or HTTPS. And from those structured calls, you'll get structured data back as returns. And that is important because in the previous, when we've done some automation or some scripting, we would have to do screen scraping, right, to find the right data, parse it out, and grab the data out of there. And if something changes in the way the CLI returns the output, that whole script breaks because it can no longer scrape that data. So the structured nature of API removes that problem and returns data in a structured way where there's a key and a value that comes back to it. ACI, of course, been built with open APIs, so it allows us to access and interact with the environment over HTTP or HTTPS right out of the box. With that, we're able to, as network engineers and network operators, we're able to take our programmability skills, right, and apply them to these platforms. But with that comes complexity, right? So if anyone ever used Python, it's great, but it's still a little bit complex, right? There's a learning curve to it, and it's not native to network engineers and network operators to start working with Python and access these APIs natively. So the solution to that is to use an automation tool. In this case, we'll talk about Ansible. Ansible will take that API programmability functionality, and it'll abstract away the coding functionality that's required to access those APIs. It'll abstract the Python that's behind the scenes that's doing the code, and it'll make it more simple, right? And so with that simplicity, what you get is human readable code, right? So it's a lot easier for a network engineer, network operator to start getting their hands dirty in this and be able to look at something that's called an Ansible Playbook and be able to read it and map it exactly almost one-to-one to what would look like in a CLI config, right? So with that, there's no special coding skills that are involved. Tasks are executed in order, and as John said, it's important that we take this automation and we have it spread through all the teams throughout the organization. And with that, Ansible is a tool that will not only work on your network devices, on your firewalls, on your load balancers, but its original use case was with servers and applications. So you get that full stack, right, automation with something like Ansible. It's super powerful. It allows you to do workflow automation, network automation, and configuration management. It allows you to do compliance management, right? To be able to look at a piece of network device that you've configured and make sure that that configuration hasn't drifted over time into something that's no longer useful, right? To be able to check on that configuration and make sure it still falls in line. Another great part about Ansible, it's agentless. There's nothing to install on the switches, on the devices. It uses the native SSH or API access that the device already applies. So there's no agents to update, there's no agents to exploit, and it uses the built-in security architecture that the device uses, right? Whether you're using local authentication, whether you're using Radius or certificates, right? It'll just use that authentication that's already built into it. And with that, let's dive into the demo. So I'll stop sharing this screen. And we'll take a look at some demos. All right, and you should be seeing my remote desktop session here, my screen with two terminals. So on the left-hand side, we have a Nexus, a virtual Nexus 9000. Its configuration is pretty clean, just basic config to allow management access. And on the right-hand side, I have a window into a Linux workstation that has Ansible installed. So let's take a look at what makes Ansible really work. There are a few components, and we'll take a look at these together. Files are stored in a directory, any directory, and most of your files or your playbooks, playbook is like a recipe to run to configure something. Part of that directory will have a couple components. One is the inventory. Inventory is what are you running this script against. So the first line shows NXOS v1. That's a host name that's resolvable. And underneath, there's some user variables such as username and password. So that's who we're running. If there are more than one device, you would just list them here, NXOS v1, NXOS v2, or you could have IP addresses listed there. Next is our external variables file. We'll probably take a look at that in a minute. But first, let's take a look at our main playbook. This is a very simple playbook. It creates VLANs. One thing I didn't mention is these playbooks and Ansible language is based around something called YAML. YAML is a markup language that's meant to be very easy to get started with and, again, human readable. So basically, we're going to create, and in this playbook, we have a few different ways to create a VLAN. We're going to create 3 VLANs in this example, and it's going to be VLAN 10, VLAN 20, VLAN 30. We see that we've defined a variable here, VLAN 20. Its ID is 20, and name is app. We also have an external variable file that we reference here. We'll take a look at that variable file, but all it's in there is another variable just like this, and it's VLAN 30. And here's our actual tasks. We have 3 tasks. The first task is ensure VLAN 10 exists. We see that it's very easy to read. This first line talks about what module we're working with. In this case, we're working with the NXOS VLAN module. We have a VLAN 10. The name is web, and the transport we're using is NX API. So basically, there's 3 tasks, VLAN 10, VLAN 20, VLAN 30. And this demo shows you how we can create things. You know, here it's statically mapped via static 10 ID. Here we start to use variables. This VLAN 20 variable comes from up here where we defined it. And this VLAN 30 variable comes from the external variables file, and it's defined there. Let's take a quick look at the external variables file. And here it is. Just like I said, VLAN 30, ID 30, name database. Before we start, let's take a look at our switch. Make sure those VLANs aren't on there. And we see that all we got is just VLAN 1, the default VLAN. And let's go ahead and run this playbook. So Ansible playbook, we're going to run it against the create VLANs playbook, and we're going to include the inventory file. So there's some purple, we can ignore that, that's some deprecated commands, but it tells us that it's changed. There's 3 tasks that it ran. VLAN 10, it's changed, it's VLAN 20, it's changed, and VLAN 30 is changed. If we now come over here and take a look at it, we can see that we have 3 VLANs that have been created, 10, 20, and 30 with the appropriate names. Now, part of what I talked about is compliance. Make sure that things haven't drifted from the config that you've intended to have on here. So you can run a playbook against the device as many times as you need to. And if there's no changes to be made, it'll tell you that there's no changes to be made. So I just ran that playbook against, and it tells us that it's all okay for those VLANs. There are 3 okay, none have changed. Let's say somebody comes along and for some reason deletes VLAN 30 or VLAN 20. Things have broken. Now, as a part of the compliance, you can run this script again, and it'll go in and run against it. It made sure that VLAN 10 existed, didn't need to change anything, but it did notice that VLAN 20 didn't exist anymore, and it changed it. It brought it back. VLAN 30 was all good, and in our recap, it shows us that 1 is changed and 3 are okay now. If we look at our VLANs, VLAN 20 is back in play. Let's so this is a brief look at how NXOS could be used with Ansible. What we'll jump into next is a little bit more real-world example, right? And I created a custom script here, and the thought behind this is you're deploying a bunch of top-of-rack switches, right? They're all going to be the same. They're going to have downlink ports that go over to your servers. You have your uplink ports that are going to go to an uplink switch that are inside of a port channel. We want to set the host name to be the serial of the switch. We want to set some NTP settings, some DNS settings, and things like that. So let's jump on to NX02 here. I'm going to log in. And we see that its host name is NXOS-v2. If we do a show run, we see it's mostly empty, other than some management config. Let's take a look at our Ansible playbook. We'll start with taking a look at our external variables file. External variables file is very simple in this case. It defines some VLANs that we're going to create, the name and the ID. Let's take a look at the playbook. The playbook is called New Switch. And I'll go through each of the tasks here one by one real quick, and so you can get an idea of how it's human readable, how it maps to the switch. One of the first things we want to do, well, here's the initialization. It tells us we're going to use external variables. The very first task I want to do is gather some hardware facts about the switch. From this hardware facts, I'm going to be able to get things like the switch's serial number. And I'm going to use that to set the switch's host name. Here you can see host name is going to be set to Ansible serial number. We're going to set the domain name, name servers. We're going to set some NTP config. We're going to create the VLANs. Now, in the initial demo that you saw, we had a task for each VLAN. Ansible with automation has ability to loop through things. So in this case, we see that we're looping through that VLAN's external variable file, and we're setting the VLAN ID and name for each one of the list items inside of that external file. We're turning on NXOS feature, LACP. We're going to create our port channel. We're going to call it group 100. We're going to put some numbers into them, mode active. And as you can see, this maps very closely to traditional CLI config. This is not very codey, but rather it's more like a CLI that you can read as a network engineer. We're going to set our allowed VLANs on the trunk. We're going to make it a mode trunk. And here we're going to set the downlinks. We're going to do a little bit more looping. We're going to say, we're going to choose our interface, and interface is going to be /, and it's going to have a variable name item. And our variables are going to loop from 1 to 6. And we're going to set the VLANs allowed 10 to 11. And that's it for now. So let's get out of this script and let's run it. So right now it's gathering the facts from the switch. It got the serial number. It went ahead and configured some of the system settings, the NTP. You can see it created VLANs, turned on feature LACP. Here we are setting our downlink ports, and we're configured. So now, right off the bat, you can see the host name changed. It went from being NXOS v2 that was earlier here. Now we've set it to be the serial number. We can start looking at things like port channel. We can see a port channel has been created. We can see that our interfaces are now configured, right, for port channel, and our downlink interfaces are configured. We can see things like NTP is configured and DNS. And again, compliance management, right? For some reason, somebody comes along and gets rid of NTP server. You can run the script again to make sure the switch is still compliant. It'll go through it and only change the things that are no longer compliant, right? And we can see everything is greened except NTP. And we're going to go ahead and set that back. And it's checking the downlinks now. And it's good to go. So as you can see, this could be a very powerful tool in deployments where you have to deploy a lot of switches where automation makes sense to reduce the human error, to reduce the complexity, and reduce the time spent on the whole solution. And out of it, you get a better output, right? Better product that's more complete, more compliant with less errors. With that, let's jump into our ACI Ansible demo. And this demo is going to be pretty quick. Now that we've looked, I might have take that right. Now that we're familiar with Ansible playbooks, we'll take a look at an example of where Ansible could be used. Where Ansible could be used with ACI to, in an environment, for example, the idea behind this demo is an environment where you're having operations such as DevOps or maybe multi-tenant operations where you're constantly spinning up tenants, you're creating bridge domains, VRFs, you're creating things like EPGs and application groups, creating contracts and mapping them. And it's a lot of clicking to do this. And again, a lot of error-prone things to be introduced with a lot of human interaction, where this could be automated and simplified through a script that it's very, if it's very repetitive, you just change a few variables in the script, run it, and it creates the output for you right into Cisco, into the ACI. In this case, we're going to create a tenant, we're going to create a VRF, we're going to create a bridge domain and some EPGs and map some things together. So let's get right to it. All right, let's take a look at our actual playbook, and we'll go right through it because we're all pretty familiar with Ansible now. So tasks. First task, we're going to create a tenant. Tenant name. Well, first of all, in most of these tasks, you'll see host name, username, password, right? This will refer to variables that are set in a variable file. But the tenant we're going to create is ACI Lab. Next, we're going to create a VRF. The VRF name, the description, and the tenant name is going to come from a variable file. We're going to create a bridge domain name, VRF, and tenant is going to come from a variable file. We're also going to start create contract. We're going to do some looping here to make sure that we're creating contracts for each of the EPGs that we're going to need. We're then going to create an application profile. We're going to create our EPGs. And again, we're going to do some looping through the EPGs. And we're going to start binding contracts to our EPGs. We're going to have providers and consumers of those contracts. And that's it for the YAML for the playbook. Let's quick peek at our variable file. In our variable file, we have some definitions such as VRF, bridge domain, application name, the tenant, the contracts that we're going to create, the endpoint groups that we're going to create, and how they consume the contract, right? Who's the provider to a contract? Who's the consumer to a contract? Let's go right into it. Ansible playbook, create. And we're going to specify inventory. And you can see things are happening on the left as they're happening on the right. So we've, in these few steps, right, we've created a tenant, bridge domain, VRF, EPGs, application profile, and grouped and mapped contracts. So we can see there's a new tenant, ACI Lab. In the tenant, we can go ahead and see that there's a new app, 3-tier app. There's 3 applications, EPGs created, app, DB, and web. We can take a look and see now that there are contracts created, right? Application contract, database contract, infrastructure, and web contract. In the networking section, we're going to have a bridge domain that's been created. We're going to have a VRF that's created. And then if we go over into our application itself, in here, we can see that now we've already created the mappings, right, between each of the endpoint groups down here and the contracts that they're either providing or consuming, right? So imagine you had an organization that was spinning up development and test of the application, and every time you needed a new development area, these are the manual steps. You'd go in here and create each one of these components. And you can imagine this would be very error prone and very time consuming, where through scripting, through automation and script with the external variables, you just need to change a few things and off to the races with a complete automated solution. With that, I'm going to go ahead and turn it over to John. This concludes my demos, and I'll turn it over to John for his part of the presentation.
Great. Okay. Let me share my screen here. Make sure you guys can see the right content. Igor or John, can you confirm you're seeing that correct screen?
Yes, sir.
Awesome.
That's good.
Okay. All right. Thanks, Igor, and hello, everyone. Yeah, my name's John Moorhead. I'm a senior solutions architect with SMP. Been here a little bit over 6 years. Been about 30 years of experience in the IT field. John mentioned about Multisite. Yes, we're going to be demoing Cisco Multisite, ACI Multisite, and that's really a component of Cisco's ACI Anywhere, which is really not a specific product, but it's really ACI Anywhere defines a cohesive set of solutions and technologies from Cisco that really allows customers to securely and extend their data center fabrics to other on-premise locations for private cloud connectivity or to one or more public clouds, or even a hybrid type of design. So, the solutions we're going to talk about really allows customers to really extend their data center policies and constructs in really a consistent manner, allowing for them to safely and easily enable and take advantage of multi-cloud architectures. So we're going to talk a little bit about, go through a couple slides, and then we'll jump into the demos. So if we take a look at what's really happening in the data center today, a lot of us still may think that the typical data center is bricks and mortars. However, we all know there's really a major shift going on, and the data center is not really centered anymore. It's rather really shifting to cloud computing architectures, right? So data is being relocated to closer to the apps, which may be in the public cloud now, and that may facilities like colo facilities and companies like Equinix allow customers to take advantage of exchange fabrics that really bridge the gap and solve specific issues for connectivity and data access for on-prem users, public cloud applications, and really the data that needs to be consumed. 5G is generating more bandwidth and requirements, and really the proliferation of IoT devices is really generating more and more big data. That customers need to analyze, process, they mine it, and really to be used to improve business outcomes. So with all that said, applications are really active everywhere, on the network, and that's the data center is really no longer defined or confined to a specific place, but it's more of a nerve cluster, if you want to call it that, situated wherever the data is. That data could be anywhere, along the whole edge cloud, continuum. That data is generated at the edge a lot now, and data is typically processed on-prem or in the cloud. Wherever it makes sense these days to, customers need to execute at speed. They need to be ready and able to provide intelligence. They need to be ready for change, for growth, for whatever really the organization needs. So it's extremely dynamic these days. That's where, Cisco Anywhere really helps organizations, to pivot quickly and securely. It's kind of hard to believe, but it'll be 7 years actually this November that Cisco ECI has been delivering application agility in the data center. So Cisco ECI was built upon their policy-driven automation framework. So within itself, there's a lot of automation, and that's centered around that application policy profiles. And Cisco ECI provides the tools to automate the network, the network services, including firewalls, load balancers, etc. And it also allows to be integrated with third-party automation tools, like including vRealize and other cloud automation tools that's out there. obviously Ansible as Igor went through. And the capability of ACI was really initially focused for on-premise infrastructures, but Cisco has really now extended these capabilities to multiple data centers, really bringing them under a single policy automation framework, and allows customers to scale their infrastructure really with security in mind. And customers are really moving, their next generation apps to the public cloud. So we see that that's a major shift. And Cisco ECI and ACI Multisite solutions really offers the capabilities to really enable those business critical applications to have a consistent posture across their both on-prem and public cloud footprint. So really in a nutshell, that's really what ACI Anywhere, the vision is, really enables customers to extend ACI automation to any location with security and scale. And in addition, it provides deep visibility and analytics into the infrastructure, really no matter where that workload it resides. So we really see Cisco ECI as the foundation that really enables and assists customers on their digital transformation journey. ACI really allows customers to optimize the network, protect the business, and accelerate cloud migration and adoption while minimizing security risk. Multi-cloud architectures also, impose potential vulnerabilities and risks to an organization if they're choosing to only use native-only public cloud networking constructs. Most customers that we work with today really, for the bricks and mortars, they really don't, in the data center, they really don't mix vendors with their on-premise data centers, really. So really, thus, organizations should want to, in my opinion, mandate that extending their data center infrastructure fabrics, policies, wherever that may be, should be in a cohesive and consistent platform. So with that said, it's really easy to understand the value that Cisco ACI Anywhere and the solutions it provides really allows customers to have that familiar single vendor approach for business critical applications and workloads, no matter where they are consumed in a multi-cloud architecture. So really another benefit of Cisco ACI is really the diverse ecosystem of partners that they support. One internal such integration really exists between ACI and AppD, where Cisco really offers a cohesive solution for data center networking and application performance. That ACI and app dynamics really collaboration provides, application and network teams. That really provides those teams that being able to correlate between application visibility and the network itself. Customers can really quickly reduce the time to root cause analysis and identifying issues, whether it's the network or application, and do that proactively. So they're not constantly pointing like, no, it's the network, no, it's the application type of thing. So that's a key, very key integration there. In addition to what we're talking about with Ansible, you can see ACI is very open, supports SaltStack, Chef, Public Terraform, and many others when it comes to automation. In the application delivery and control market, ACI integrates with F5, Citrix, A10, and others. And as suspected, as probably a lot of everybody knows, ACI pretty much supported and integrated VMware from day one because obviously they were the leader. And now ACI supports Hyper-V, Docker, and others for workload management. ServiceNow is a very popular ITSM solution and integrates with many vendors, not just Cisco, but it integrates with multiple Cisco products, including ACI. And lastly, there's a slew of security integrations. I'm not going to go over there, but only a few listed on this slide here. So let's review briefly, the values and benefits that really ACI provides, and allows customers to automate and optimize the data center. Really out of the box, ACI automates that underlying, the underlay network in a very simple and easy fashion. So bringing that up is very quick and easy. The overlays and other constructs that in ACI can be easily automated with Cisco Multisite, which we're going to demonstrate, and other Cisco solutions, and as well as open source tools, kind of like that we reviewed in the last slide, and Ansible is one of them. So ACI, along with their network assurance engine that Cisco provides, allows for really a fastest time to problem resolution and root cause analysis. And lastly, scaling, is vast in ACI, not just in one physical data center. that's where Cisco ACI Anywhere comes in a lot, provides that geographical scale. So let's really take a look at how ACI Anywhere, how it's grown over time in ACI 2.0. You had the pretty much the single availability zone for single sites that might have been close to each other to do like a stretched fabric, via multipods and other constructs that ACI had. And that kind of, the next major shift to 3.0 was the multi-site, which then allowed not just the local availability zone, but the multi-region geographical, high availability and redundancy with multi-site in 3.0. 3.1, offered remote leaf. We'll talk a little bit more about that briefly. And 4.0 offered the concept of virtual ACI. And again, we'll talk a little bit more about that as well. And obviously 4.1, that's where extending ACI and into the cloud with with the multi-site capability. So we'll go over some of the components, the Multisite Orchestrator, like I said, the virtual ACI, the remote leaf, things like that. Really, ACI has been, from a top down, starts with their APIC with the controller, which then controls the fabric itself, which is built on the Nexus 9000. That really creates that spine leaf architecture, allowing 40, 100, 400 gig fabric. That's really where the basics, building blocks of ACI. So the multi-site orchestrator really it enables that connectivity between multiple ACI deployments, whether that's two physical data centers on-prem or extending out to the cloud or virtual. But that's where the multi-site orchestrator, or MSO, you'll hear that term as well, that provides that single pane of management and consistent policies, allows that geographical high availability and scaling. So the thing we talked about briefly was the remote leaf, which is typically for on-premise. Customer may need to extend their data center to a tertiary or more sites that just have a very small footprint that they need to run critical data center applications. They want to push that policy down without having to deploy controllers, APIC controllers, physical controllers. So that's where the remote leaf comes in as a solution option, which can be controlled underneath multi-site as well. The virtual pod for customers that are starting to leverage going to, maybe have a colo facility or some sort of bare metal provider or some sort of provider that gives you access to get closer to those cloud providers. If you need it for lower latency requirements, things like that, that's where a virtual pod may come into play and fit well for a customer. The ACI also offers a mini fabric. It's great for small to mid-sized businesses, very small footprint in a rack space perspective. There are some limitations and caveats with MSO. It does support underneath multi-site orchestrator, but there are some limitations and caveats. So if there's any interest in that, just let us know. We can dive into that more. We're not going to be going in any further on the mini fabric on this today. And the multi-cloud extensions, I talked a little bit about, Equinix and other cloud exchange providers like them, really allows customers that, to provide the capability of if they're in an issue where maybe they don't want their data to go up the cloud, they still want to maybe keep a copy of their data or have their primary data only be on-prem, or have it on-prem might have a challenge where they want to have compute and processing up in the cloud, but having go from their physical data centers to where that compute is out in the cloud may that latency to get that direct connection still might be too much, and they might need a better performance. So going with a cloud provider, getting data, potentially having their own storage array at a cloud exchange, very close, very, very high speed, low latency requirements. Maybe they don't want the data in the cloud, like I said, for a multitude of reasons, maybe compliancy, maybe cost too much to pull the data back if they, if they had to bring the data back. A lot of slew of reasons for that, but having these types of architectures and being able to have a consistent policy with with multi-cloud and having ACI multi-site being pushing that consistent policy is really where the value is. So with that said, we're going to jump into some of the demos, just to talk a little bit about that before we get in there. This is the demo environment. Really has two sites in the demo environment, and we're going to have one site's going to be termed San Francisco, the other site's going to be New York, but obviously multi-site supports 2 or more locations, and that's one of the 3 functional components of ACI: 2 or more ACI fabrics, obviously built upon the Nexus 9000 switches, and in each cluster there's an 8-PIC cluster. In each fabric there's an 8-PIC cluster, and the other main component is really that Intersight policy manager, the multi-site or MSO, which is really used to manage the different fabrics into a consistent policy. So the other thing I just want to mention before we jump in is really the benefits. 3 of them I just want there's more than 3, but the 3 I want to mention is the multi-site is can really be configured to be shared or isolated, meaning that you can share services or isolate services. So if you need to have services that are local only for a site, you can do that. You can share services across. Just think of it as, hey, I want to stretch an L2 and have services consistent across both sites. I'm going to stretch that. We're going to show that a little bit. Or I only want to do an L3 stretch, not stretching L2. That's probably one of the most common use cases. The other thing that's benefits is ACI multi-site uses BGP EVPN for the control plane, and it leverages VXLAN encapsulation for the data plane. And lastly, the multi-site really extends that policy end-to-end across the fabrics. Really, you create these policies in the GUI and you push them to all sites or selected sites, like I said before. And you can do this where from a greenfield perspective, where you're creating them all at once, or if you already have an existing ACI, you can do it from a brownfield perspective where you can import that. We're going to show that in the demonstration as well. So let me get out of here and bring up the demo site. A second here. And one thing I did want to mention, I just pulled this up, is that Ansible does support all the ACI constructs. And if you go out to Ansible, if you're interested and you guys want to leverage Ansible a lot, even with Multisite Orchestrator, there is these modules. You can look at all the Ansible modules. There's a lot of ACI modules. There's 33 for Multisite Orchestrators you can see here. If you just go to this and you're gonna look, there's 60 some, probably like 69 ACI. Scroll up here. Yep, ACI. If I do ACI underscore, there's 67 ACI Ansible modules. There's a lot of things that probably most everything you can create. If not, you can do the ACI REST. So anything that's not in these easy to read, kind of what Igor was mentioning, is it's very easy to read from a module perspective. But if there's something that's missing, you can hit it through the ACI REST module. So let's dive into the Multisite Orchestrator. Let me log into these guys here. Just show you what we got real quick first. Now, we've got 2 APICs to log into. Yeah. So the first thing I want to show is just the 2 APICs. So we got APIC A. This is going to be the San Francisco site. And if we look at the tenants that are built in here now, we have a brownfield, which we're going to show, where this is not configured over in our other site, which is the New York. But you can see it just has the common, the infra and management, which are the default tenants that come out with ACI. And then over here on our New York site, you can see our tenants. And here we just have the three standard tenants that come by default. If we go into the MSO, this has already been pre-configured. If you guys want to, if anybody's interested in learning more about or want to see a lab on bringing up the MSO, bringing in the sites, because if you can see in here, if I go to the sites, the New York and San Francisco sites have already been brought in. If you want to see how MSO is configured from an APIC perspective, we just don't have time to show that level of just bringing up the multi-site orchestrator, bringing in the sites. If you do want to see that, there's a whole lab on that, but we're just going to show some of the common use cases in creating schemas and templates and things like that, and how to push out various use cases of pushing out policies where it's locally significant to a site or shared across sites. So the first thing I want to show, we dive into tenants. So you can see here is just a common one, but we're going to add a new tenant, and we'll call this guy, let's call him Tulsa, and we're going to assign him to both sites. So we're going to create this new tenant, and we're going to assign him to both sites. Save button. So that's been saved, and we go back to the this is San Francisco and the A. You can see that was pushed out. The new tenant's already there with Tulsa, and both in San Francisco and New York that has been pushed out from the multi-site orchestrator. So that's just the first thing, just easy peasy creating a new tenant. Now we're going to just dive in a little bit more and just kind of go through like a layer 3 stretch scenario. So the first thing that you do when you're creating a new, they call it with a schema. So we're going to create a new schema, and we're going to call this schema, obviously our use case, we're going to call that L3 stretch. If I can spell correctly. And in there, once we create that schema, and we want to assign that, obviously, we assign the schema to our new tenant that we created. So we got that new schema created, got it associated with our new tenant that we created. And we also want to create this template. We're going to rename the template, and because this is going to be the common, there's going to be some common services that we need to share, which is just the VRF. So we're going to do an L3 stretch, and we need to share the VRF across both sites to do that. So we're going to call this one S San Francisco and New York template. And if we go down here, we're going to add the VRF. And there's not a VRF yet, but so we're going to create one. Save. And we can see after we save it, if we go to the sites, we're going to assign the sites to this template. And if we do a save here, and you can see here on the little exclamation point, changes have been saved, but they haven't been deployed. So if we go back in here, we're going to go into Tulsa, and we go into the networking VRF. There's no VRF yet because we haven't done the push. So obviously you need to do the deploy to sites. We're going to deploy that. Go back to our Apex. You can see the VRF1. The VRF has been pushed to both tenants or to both sites underneath the Tulsa tenant. That's common on both sites. See that's there as well. So the next thing we're going to do, just to show, just to keep time to a minimum, so we're just going to show how to keep constructs local to one site. We can show on both and then link them together with contracts, but just to show you the power of being able to have something shared across both sites and something local, we're just going to do one site in interest of time. So the next thing we're going to want to do is under here, we're going to create a new template. And we're going to rename this template to be, we're just going to push constructs to San Francisco only. So underneath San Francisco only template, we're going to obviously assign him to the same tenant. And we're going to add, say, your typical application profile. And, it's very common profile. Just for a demo perspective, web app. So we're going to do a web application profile. And let's just add a EPG to here as well. We'll just call him web. And down here, just to show you a little bit more constructs that you can do, you can see there's no bridge domains in here. Let's just call it a web BD, web bridge domain. And as you can see down in here, now the web bridge domain has been created and all that kind of good stuff. So let's go this guy. And we need to assign him obviously to a VRF, our existing VRF1. And we're not going to do an L2 stretch, so you actually have to uncheck that. There's a little warning. Yes, we know the warning. And because we're going to do this as you turn off the L2 stretch because it's an L3 only, obviously. So just to show you, if we do save there, we actually have to then assign that. If we go to the sites again, if we look at San Francisco, in San Francisco, we actually need to assign the SF only to San Francisco before we deploy it, or won't send that. So if you look on these sites, we have both New York and San Francisco have the San Francisco and New York template assigned to both their sites in the San Francisco one. And again, it hasn't been pushed yet. So if we get on that guy and we select the template and we want to deploy that to the sites, and when we go out to the San Francisco site here, we can see there should be an application profile. Obviously, there's a bridge domain, and that's how you can make them just locally significant by the use of templates and only assign them to the specific sites. If we go over to New York, obviously, you're not going to see that application profile or that bridge domain here at New York because we explicitly stated that we're going to keep them local. So the last use case I just want to show is really importing, a tenant. If you have a migration scenario, maybe you already have ACI deployed at one site and you want to bring that into the Multisite Orchestrator and then push that out to maybe another site that you're bringing up as a greenfield. So first thing we want to do, obviously, is create a new tenant. And the tenant that we need to do is this needs to match 100% in here. So again, we just had the comment in Tulsa, but we need to add the brownfield. And I showed you earlier that was called brownfield, and this has to be spelled exactly the same, or the import's not going to work. So we're gonna do brownfield, and we're going to select both sites for that guy. Let's see here, scroll down. Save button again. There we go. So now we got the brownfield tenant in there, and it's been assigned to our both sites. So the next thing we need to do is create a schema. So we're going to create a schema, and let's just call this one migration schemas. We're going to try to migrate one site to another site. And we're going to change the template. We'll call this guy migration template. And we'll select the tenant that we just created here, your brownfield. And as you can see, when you have underneath the template here, we have an option to do an import. So we're going to import, we have the brownfield in San Francisco. You have to know which one you're going to import from. We're going to select there, and you can see that they're underneath that brownfield. It actually can read that and see that, hey, we do have a application profile. We have one EPG, one VRF, one bridge domain. So we're going to import that guy. If we scroll down you can see on the bridge domain that the L2 is not selected. Obviously, we would want that for this scenario. Let's see here. So we're going to say yes. And the reason there, obviously, is you're going to want L2 stretch selected, and you're going to also want the Intersight BUM. And BUM is the broadcast, unicast, multicast traffic. And that allows you be able to do a true L2 stretch and be able to leverage, one of the most common things is vMotion. So you're going to need to allow the BUM traffic to start, if you're going to bring this in and then start migrating some workloads leveraging vMotion. So with that said, the other thing is you can save here, or you can just go right to deploy to sites. You don't have to do save then to deploy. You can just go right to deploy, which automatically saves as well. So we'll try that. See if that works. I did update that. And if we go back to our San Francisco was A, that's where the brownfield was, and we go to New York with any luck, we should see brownfield, and we do. And we see the brownfield here in New York, which got then imported into the Multisite Orchestrator, then pushed out here. And we can see that our, should have been out there. But I guess the demo guides are not being helpful for me. But let me see if I missed something here on here. Right. But I'm not going to troubleshoot that. But that's, you can trust me. I'm leveraging on a demo site. I might have been having an issue here, so that should have been imported and saved over there, but I'm not going to troubleshoot that because we're in interest of time. And with that said, I think that ends my demonstration, and I'm going to hand this back over to John Klossner.
Thank you, John. Just 1 second here, and I'll get shared out as well. All right. So I'm going to wrap us up. John and Igor, again, thank you guys. Hopefully it's easy for folks to see the power of programmability so far, right? So we're using it in Nexus, in ACI from an Ansible perspective, and then also within ACI with the Multisite Orchestrator. And as John showed at the beginning of his presentation, there's Ansible support for MSO directly. So all of the steps that John went through there manually could be scripted in Ansible to accelerate that deployment. So the next thing we're going to talk about is Cisco Intersight. For those of you who are not familiar with Intersight, Intersight is a SaaS application to support all of the Cisco compute platform known as UCS. So from the diagram here, we're showing connectivity to UCS Manager, which is what runs the Blade-based systems. The IMC software, which is think of it as your out-of-band management brains to any of the chassis-based systems. HX Connect, which is the HyperFlex or the hyper-converged offering from Cisco. And UCS Director, which is similar to the MSO that John talked about, that actually can do orchestration within the UCS compute platform. Also represented here are connectivity into third parties via the Assist appliance. So this is a virtual machine that would run on-prem in your UCS environment. Currently works with Pure Storage and VMware vCenter to allow some control there as well. And the circular with the plus logo up here, that's Cisco TAC. So I guess that's meant to symbolize a little health symbol. But if anyone's familiar with Meraki and the way the Meraki dashboard works, and if you call into Meraki support, Meraki can also view what's going on. That's really what this is representing. So you have a direct line from Cisco TAC, and one of the slides here coming up will actually show you that. So in its simplest form, and there's a few different variations of this, but in its simplest form, Intersight can detect if there's a hardware failure. Say, for example, a disk, memory that's getting a whole bunch of errors, power supply that's gone bad, and without your team having to do anything. In fact, we've got a couple clients that are using this today. They'll get the email from Cisco Proactive RMA before they even realize that they have an issue with the device. When that email comes, that means that the RMA has already been generated. The part is already on its way. Okay, so really speeding up that time to resolution. It also helps if you have to open a TAC case, for example, and TAC will typically want you to gather a whole bunch of log files and this information, that information. You as a user in Intersight can actually go in and grant Cisco permission. It will upload all of those files automatically to your TAC case because you enter the number, and Cisco will have access to everything. So I've seen examples taking that duration of getting the case open to resolution drop from hours to 27 minutes, right? Just in terms of eliminating a lot of the back and forth and getting TAC the information that they need from the get-go. As both John and Igor talked about, the biggest commonality here between all of the things that we've talked about today is a RESTful open API. So Cisco has embraced this across many, if not all, I think, of their offerings to date. We operate with all of the tools, right? So I think John and Igor talked about Ansible, but there's others out there as well, maybe some lower levels or lesser known tool sets. Ansible is actually owned, I think, John, keep me honest here, by Red Hat today. I think they own them. But just so you're aware, it's a piece of the puzzle. If you're looking for some more details around what I'm going to show you here coming up in the demo, there's a number of resources out there to take a look at. DevNet, if you're not familiar with it from a Cisco perspective, I know that the majority of the folks on the call from the SMP side here today are intimately aware and becoming more so every day with DevNet. A bunch of sandboxes out there, a bunch of learning that you can do at no additional cost. Software development kits are out there. Again, the beauty of being open, which is really a necessity in today's world. So with no further ado, I'm going to jump into the demo here for you. With a little nod, John or Igor, am I showing the right screen? You see a UCS?
Yep.
All right, perfect. UCS Manager. So, gang, if you're not familiar, UCS Manager is a piece of HTML5 based code that runs on, I'll call it a rebadged or re-imaged Nexus top of rack switch that not only provides a data path for blade chassis and rack mount servers, but also provides all of the management, identity, configuration of those devices. I'll give you a quick overview here. So in this case, we've got a pair of fabric interconnects, FEXs, which are an extension or a remote line card. If you think of in the switching world, you've got a couple of 8-port or 8-slot chassis connected up, a couple of C-series, which are the rack mounts connected in here. We can dig a little bit deeper, right? So we can start looking into the fabric interconnect, modules. We can look at servers. And of course, nothing's going to show up. Let me jump into, I think this is devices. Here we go. Where is it? There we go. This is what I was looking for. So you can get a nice graphical representation of what the chassis is in there, what servers, if you want to click into one and get more detail on it. There's none going to show up. So this is a demo system. This is a sandbox running on DevNet that we talked about. So not everything here is necessarily fully functional. But the one thing I want you to take away on the UCS Manager, the first step to connecting to Intersight, the SaaS model, is one easy step. It's down here at the bottom of settings, device connector. I've already claimed this one into Intersight, but if I had not claimed this, you would see a device ID and a key that you need as you register into intersight.com. So that's already set up for us here. Jump over to Intersight to walk you through some of the dashboard here. Now this is where Cisco is headed from a management perspective. At some point in the not so distant future, UCS Manager will not be a requirement. Intersight will be able to manage a lot of these devices without having that additional layer. In fact, HyperFlex, the HCI or solution on the edge, which are the smaller form factor, the 2 or 3 device nodes, actually don't require fabric interconnects today because they're managed 100% from Intersight, from deployment all the way through operation and upgrades. So just to give you a little look in here, again, the look and feel is a little bit different than UCS Manager, right? Today it's not meant to be a replacement. We can again drill into, let's see, come on, demo gods. Sometime now, there we go. Can drill into any of the different categories. We can see that there's a bunch of healthy servers out here. Cisco apparently doesn't have their own virtual labs on SmartNet, which can be a very useful item for clients to understand what's out there. It'll also tell you if anything's coming up to expire. One of the other cool features over here is you can actually launch, depending on the software license that you have, you can actually launch into a tunneled KVM. So if you're not KVM is keyboard, video, and mouse is the terminology. So you could actually, via Intersight from anywhere in the world, hit your site, tunnel through Intersight into your on-prem environment as if you were sitting at the keyboard in front of that server. All tunneled, totally secure, encrypted end-to-end, which I'm not aware of anybody else that has that type of ability. So again, that's out here. Just trying to think what else I wanted to show you guys. So under the settings here, under licensing, these are the different tiers that are available to do any of the automation programmability stuff that we're going to show you today. You've got to be actually an essentials tier. Base is free, it's included with any UCS purchase. Essentials is a subscription model. And this demo system is actually set up at Advantage that gives you a few other things that we'll be happy to get into the details with you if you'd like. The next thing I'm going to show you is to begin down the path of using APIs to integrate with Intersight. One of the key things that you have to do are generate the API keys. So this is where we would go to do that. Again, we're under settings, API keys, generate that guy, give it a description, test API key. I'm going to generate that. And this is basically an authentication tool set, right? So you don't want anybody to be able to run APIs against your system. Here's the key ID, and then there's a secret key. in your tool sets like Ansible, there's a place to load these files into, but that's as easy as it is to generate. Okay, just so you'll see that. The next thing I want to show you is if I come up here to users. This is a pretty simple thing. I'm the only one that's configured in here right now because of the lab. One of the beautiful things about Intersight is literally everything that you do within Intersight can be controlled through an open API, a RESTful API. And it's documented very well. I'll show you that coming up here in just a minute. But just so that you can see, if you actually open up and inspect every command that we run through here, if I were to add a user, you'll see things start to populate here. I'm going to add John, come on, my mouse, John Moorhead at SMP-Corp.com. And add him as an administrator. I click save. I actually come over here and I want to then take and run this through Ansible or Python or Postman or any of those tools. Oops. I can go in here and I can actually see all of the information that I need to construct any of this through an API, right? So the object is I am user. We're going to set it. The email is that. I didn't enter a first name. And then it'll also set the permissions as well as we go down through. So that works any tab, any operation, it all shows up there. Nice and open, nothing hidden at all. If I come over to this tab, so this is logged into the same Intersight that I'm working from right now. Starts out with a guide. So there's a whole bunch of detailed information that you can get into here. If you want to download these documents and SDKs, Python, Ansible, as Igor talked about, the YAML format, Intersight ITSM plugin for ServiceNow, these are all there accessible for you. But even in its most basic form, so every API that's in here is listed in this API reference. If I come in here, for example, and I'm old school, I don't know nearly as much as John and Igor do about programming. So I stumble through this a little bit, but I know I want to look at something from the compute side. I know I want to understand something physical about my blades that I have in the environment. I can do a get command, so it'll actually give me all of the detail. If I go down here, I got to pull up another doc. So if I just run this command, right? So right here, I do a get, ends in physical summaries. This browser, this is actually a RESTful client built right into the tool set. So I can actually try anything I want here. I actually get, let me slide this over so that everyone can see that a little better. We'll get the actual output from that command in this response text down here. It will show me the physical summary, the license that I've got for every single blade that's in the environment. See, so this is actually a C series, a C220 M5L, so it's a large form factor on the drives. Tells me what version of firmware it's in there. So every bit of information from a hardware perspective is here. Let me see, let me click back over here. Two things I wanted to show you. So that's not it, but apparently I closed that window. I actually did want to do a more precise query here for you guys, but I believe I closed it. But it started out with select. Let me see. Give me one moment here. Oops. Clicking around in the RDP instead. Back in here, and here's the value. So this is all that I care about. So I want to know its ID. I want to know the available memory and the number of CPUs. I send this, and it actually basically pairs that entire report down. Where is it here? I can see in this blade, I've got 49 gig, 48 gig of available memory. I can see where it is. It's a rack unit 1, number of CPUs 2, and on, right? So all the queries, every modifier that you want is available here. And you can actually turn that guy on or off if you wanted to. But again, all of this stuff, the tool sets that John and Igor talked about are in there. I keep doing that. The only other thing I wanted to show with you guys, and I think John did this on the ACI side as well, but within Ansible, there's a bunch of modules already available within UCS, so within the compute platform itself. Intersight is not as fully developed, so there's a couple, so you can actually do a gather, and then all of the RESTful API pieces that we went through today. All right, so that's the end of the demo.
Yeah, hey John, there's also more. If you go into Cisco's GitHub, they do have more Ansible modules and examples. So just Google it. It just hasn't been updated on
Yep.
the Red Hat Ansible site yet, but there's a lot out there.
There you go. So that's here we go. I think, is that the link, John? The GitHub UCS?
Yep. Yeah, there's a whole, yeah, exactly. You hit it. Yep, that's it.
Yep. Yeah. Thank you, sir. So if we skip ahead here, kind of to wrap things up, again, as we talked about at the beginning, there's value in doing automation within each, we'll call it technology silo, but the true value to the business that we're all going to strive for is by combining a lot of these together, right? So you're not going to be able to use a Cisco ACI MSO by itself and Intersight by itself and ACI by itself. The value comes as you move up the stack, right? And you use a tool set like an Ansible that can actually orchestrate between many, right? So in closing here, our call to action for everybody on the call here today, we'll be sending out a link to a site called Pluralsight. This is actually one of the leading Ansible training organizations. And you can sign up for a free 10-day trial. So that, and Jennifer, keep me honest here, I think that's going out in an email here shortly.
That will actually probably be coming out in, let's see, the next day or two.
Okay.
It should be an email. Yep. Perfect.
And the second item, and this, really is where we view some value for everyone here. Everyone's got tool sets. Everyone's got a different environment. There's no one size fits all. So SMP is offering to the folks here on the call and others a programmability workshop, and we'll do this virtually over the course of about 2 days, and it would be someone, John, Igor, myself, another member of the team, to work through what you've got, what's the biggest bang for the buck, what are some things that you can do with what you've got, and if there's other investments needed, help you identify that. That runs roughly around $5,000 for that couple days and follow-on education. But we're also offering up to 100% credit for that workshop should you pursue any data center related purchases with SMP in the 6 months following that engagement. All right, and Jennifer, again, I think there's more details coming out about that to follow. But again, reach out to any of us. I don't think there was anything in the Q&A, but we're here to support you guys and everyone here, and let us know what we can do to help. Thank you all very much.